So this is actually a very non-deterministic program because what happens here is that the parent can run first and the child can run second, or the child can run first and the parent can run second. If you want to try it, you just run this program like 20 times and you'll find statistically the parent and the child should alternate equal number of times. So Linux has a solution for this, and this is wait. And wait is basically a call that instructs the parent to not run until the child exits. So right now, for example, you fork again, split, clone yourself. If less than 0, then you have failed. If it's equals to 0, then you're now at the child. But look at the parent. The parent basically has the call wait. And wait with an input of null, with an argument of null, basically means that the parent should wait for all its children until they finish before it continues running. So if you run this program 100 times, 1,000 times, it will look always like this. You will always have the child running before the parent. Never the opposite, because wait will basically force the parent to wait until the child finishes running. Okay, so now as a user for this system call, I am able to make a child that is an identical to the parent. How is this useful? This is not really useful because you might want your child, might want the new child, the new process that you've just created, the child process, to do something completely different from the parent, having a completely different set of variables, and so on. We'll actually talk about how Linux does that elegantly, because the way that Linux does that is quite elegant in general. But right now, this is like more general to more systems. So Linux has an exec system call. And exec is your way of actually implementing a new program in the child. So if you go through this code, again, it's like you fork. Now I'm split. We have exactly the same data structures. We have exactly the same everything. But then you go if rc equals 0, if I'm on the child process, then you print the previous print, and you basically have some uh, some input like my args0, my args1, my args2, and and you could and these three you can then pass to exec, basically passing to it my args0 is wc. Wc is word count. It's a Linux call that you can just try. You give wc, if you do not know the command, you give wc file name, and it goes in and it counts the number of letters in that file, the number of words in that file, and the number of lines in that file. It's a very neat tool. So here, the exec system call, now exec has multiple variations, and this one is exec vp. So the exec vp system call basically goes in and starts executing my args0, which is basically wc, and then passes everything, all the other arguments to it, which is basically the name of the file. Okay. So now exec will execute the call for wc. Now it has gone into a different direction from the parent. It loads a different call, it does different things, and so on. So if you do this, then you have split from the parent, and now you're no longer in this block. So this shouldn't print out. This print will not print out because now you're no longer the cloned child. You're now a new child. So it's like the way that Linux thinks about making children in making children processes in operating systems is that it clones the parent, single parent gets cloned, okay, and then the child gets its own identity. I mean, it's a pretty weird way, but it's very, very elegant. So this would be the output that you would get from this running program, and you see that this should not print out, does not get printed. So if we look at the Unix process management, it's actually an interesting. There's an interesting thing. Create process in Windows is basically fork plus exec, and this is the way that Linux tries to implement most of its system calls. It basically tries to go for the most simple thing that you can think of. Instead of trying to create process, having 11 parameters, and yeah, getting all of these things, fork and exec are just enough to do this with way less number parameters compared to create process. Yeah. So fork basically creates a copy of the parent process and makes the child set up privileges, priorities, and I/O. We'll talk about this more when we talk about how Linux does it. And it has the same code as the parent, while exec brings the new actual executable of the child in memory.